monochromatic light wave with wavelength lambda 1 and frequency v1 in air enters another medium. If the angle of incidence and angle of refraction at the interface are 45 degree and 30 degree respectively, then the wavelength lambda 2 and frequency v2 of the refracted wave are 1. Lambda 2 is equal to 1 by root 2 lambda 1 v2 equal to v1. 2. Lambda 2 is equal to lambda 1 v2 is equal to 1 by root 2 v1. 3. Lambda 2 is equal to lambda 1 v2 is equal to root 2 v1. And 4. Lambda 2 is equal to root 2 lambda 1 and v2 is equal to v1. So here we are given angle of incidence and refraction. We can use Snell's formula and we can write 1 into sine I, that is sine 45, is equal to, then the next medium refractive index we don't know, mu into sine angle of refraction, that is 30 degree, and we can get mu is equal to root 2. We know the relation between refractive index and velocity. Mu1 by mu2 is equal to v2 by v1, and we also know velocity and wavelength are directly proportional, so we have lambda 2 by lambda 1, and so we can write mu1 by mu2 is 1 by root 2, so we can write lambda 2 is equal to 1 by root 2 into lambda 1. So this one we got the relation of the wavelength we got. Now we have to find the relation of frequency. We know frequency formula, mu is equal to v, that is velocity, by lambda, and if we take v1 and v2 as mu1 by mu2, we'll have v1 by v2 into lambda 2 by lambda 1. We already know that v2 by v1 is equal to lambda 2 by lambda 1. So instead of lambda 2 by lambda 1, we can write v1 by v2 into, instead of lambda 2 by lambda 1, we can write v2 by v1. Since numerator denominator opposite places, we can cancel and we'll get 1, which is equal to 1. So we can take mu to the other side, we'll have mu1 is equal to 1 into mu2, that is mu2. So we got both relations. So the only option that satisfies both, that is lambda 2 is equal to 1 by root 2 lambda 1 and mu1 is equal to mu2, is 1, option 1.